Thank you so much, Sven. It's really a pleasure to be here. And yeah, we talked a lot about use cases, and you're, of course, interested in those. And this is why we brought up this panel now. And I'm really happy to welcome two experts on stage. And we try to look for the best title. So those are two bit different fields. We will talk about railways, and we will talk about defense. But they have a lot in common, and you will experience this in a couple of seconds. So I would like to ask on stage Henri de Chassey from the Wabtec Corporation. He's the additive manufacturing manager and head of methods. He has a degree in engineering, and he worked previously for a couple of different companies in the automotive sectors and in the transport sector. So you had different roles within Wabtec, and Wabtec is one of the very big suppliers to rail. And what is really interesting and what really made me happy, because I had just come back from the AMOC last week from Chicago, the Additive Manufacturing Users Group meeting, many people were really mourning. There is so much production going from Germany, from Europe to the US. Wabtec is so visionary to do it the other way around. So what you did is you brought back the hubs, the production sites to Europe from the US. They were closed down there, and now you're head of that in France. Henri, the stage is yours. I'm really happy to hand over. And a big hand of applause, please.
Thank you very much, Stephanie. Hello, everybody. So just as a first slide, just really a brief highlight of what Wabtec is. We are not very well known, but we are supplier of railway parts such as pantograph, HVACs, brake, coupler. Each time you take a train which is transporting people, we have part on that. So our customers are car builders like Alstom, Siemens, Stadler. And we are also providing PCs for end user like Deutsche Bahn, like Trenitalia, like SNCF. Wabtec is a very, very large company. It's 8 billion revenue, 10 billion, sorry. And you see we have our headquarters in the US. We have kept the headquarters in France for the transit part of the company. So as I was saying, we have two groups. The first one is freight, and mainly driven by US, where we are making the full locomotives, mainly it's diesel locomotives. We are speaking about a few tons of metal, you can imagine. And on the other side, transit application, where we are really focusing on components for our customer. And how additive can help us on our daily life. In fact, we are working on two approaches. The first one is to work on new trains. Like, for example, just to understand our daily life, we have the end user asking to the car builder a new trains. Like, for example, Deutsche Bahn is asking to car builders, can we build a new E6 train? And then Alstom, Stadler, whatever, Siemens, they will ask us to give a package for the HVAC, for the brakes, for the caliper, whatever. And we will have to fit on the package that they allow us to do this equipment. And sometimes for OE market, it's really tricky because it's very hard for us to be cost efficient versus a conventional way of doing the part. When you are fighting, so again, casting coming from China, from India, it can be really, really hard, but we manage, and this is how we are doing. One very, very interesting example is brake system. All the pneumatic all the brake system are made in pneumatics for on the railway. We are pushing additive since the beginning, and this is for me the key to really push additive in the railway industry, is to think directly from the beginning in additive. And this is what we have done on this brake panel. You can see it's a 600 millimeter tall panel. We have combined more than 21 pieces together, and it's a risk of leakage that we have completely deleted. We are also able to print one panel with 3 different configurations. So it means that at the end in R&D you save a lot of times. You can print the version that the customer would like, so it's much more efficient. And in terms of LCC, as you reduce the risk of leakage, at the end it's a game changer, because normally with a panel that you have on the top conventionally made, it's a patchwork of block of aluminiums. It means that each time you add a block, it's a risk of leakage in the future. So thinking additive since the beginning is really helpful, but for that we need training. We need to push people to be, I would say, fluent in the additive rule, in the design, to be competitive. And the cherry on the cake is the weight saving. You can see that we have saved on this example 15 kilos on only this example, on the 18 which were the case for the conventional process, on the conventional production panel. And we have this saving on each bogie, so on each wheel, I would say, that you have on the train. So it's a massive, I would say, weight saving. The difficulty we have is to value this saving on the railway market. Okay? We are not like in the aeronautics where 1 kilo is roughly between 1,000 and 10,000 when you are in a satellite, I think, industry. In the railway, we are really between 50 and 100 euro per kilo. So you can see the difference that we are facing. Another example, which is the one I bring on stage, is an additive. This part was quite interesting because we had failure on the small valve that you see, the black one, when the winter is very cold, which is happening sometimes, and summer very hot. And more we are seeing that coming with global warming. And this key element is controlling the movement on the pantograph, you know, the stuff that you have to take the power on the grid. When this equipment is not working, the train will not go, of course, will not run. So it's a key issue for us. What we have made, we have changed a bit the configuration, and we have added a signal. Oh, sorry, I've changed. And we have added a signal here on the valve to add the pressure, to put the membrane always in pressure. R&D came to me and with this big, nice block of aluminium, a lot of pipe. I was saying, okay, it's making the job, but let's think additive since the beginning. And you see the example which has been made in additive. So we have completely redesigned the pieces. We have saved a lot of space. We have saved a lot of problems because now the new item is much more efficient than it was in the past. We are solving all the issue until minus 30 degrees, if I'm not wrong, because we have also to test those equipment and in the climatic chamber and push them at plus 70 degrees, minus 25, 30 degrees, just to make sure that in extreme condition everything is working. And I have added also the benefit in terms of stoppage for our end customer. Because when you have an issue on this kind of additive, the train will be stopped in the depot or on the station. And for our customer, it can be very, very, very costly. So these are two opportunities that we are bringing to market for OE, for new trains. But this is, I would say, one part of our application. The biggest block we have is for end user, like Deutsche Bahn, like Trenitalia, like all the company we are working, who are managing on their daily life a lot of people to be transferred from a city to another one. First of all, 3 key numbers. The first one is if you take all the railway company, only 10% of the part that we have are digitalized. It's really incredible, but a life cycle of a train is around 40 to 50 years. It means that on the global picture, on all the portfolio of parts we have, only 10% have 3D models. So this is the key point first to work on, to be able to get data, to be able to identify which are the parts that could be printed, because at the moment we are facing a lot of difficulties to get this information. We just have the drawings, and sometimes we just have the physical part in hand. You imagine, we have some parts running on the train since 50 years. Sometimes the customer just has the part, and we don't have any information. The drawings has been lost. And for them, it can be a very, very big cost. We have a range of 50 to 200 kilo euro per day when the train is stopped. Okay, depending if it's a high-speed train, if it's a metro, if it's a tram. We are not at the stage of the aircraft industry, but it's already a cost. The third number, which for me is really interesting, is 70% of the part that we have made in additive manufacturing are due to obsolescence reason. It means that there is a strong need to solve this issue. It's how we can push and bring added value thanks to additive manufacturing on the obsolescence topic. But if you don't solve the 10% issue that we have at the beginning, it will be very, very hard to scale up. And I would like to show you, I think it's a world premiere, the last part we have developed. It's a high-speed train doors that we have made in additive manufacturing. I think it's one of the biggest part that you will see from now for railway market. We are speaking about a part which is 2 meters tall by 1 meter and a half. It's what we call a safety part. It means that when you are two trains crossing each other at 350 kilometers, you have to make sure that the door will not open. Otherwise, you have an issue. And this is what we are really focusing on. It's how we can solve our customer issue thanks to additive manufacturing, knowing that at the moment, you don't have any machine able to print this kind of parts because they are too big. So we have tried with engineering to solve this issue by making a kit of parts able to produce at the end, finally, the doors. Of course, we did not print all the plates, but we are finding a way to print all the profile, because each customer has a different profile. You see, the trains are not the same. You'd have different configuration, and additive manufacturing can be a game changer for us. Just for your information, when a door is obsolete, it takes us, and it's not a crazy number, it's 2 years to get a part. Why? It's because we have to produce all the toolings. We have to book minimum 1 ton of aluminiums just to get all the profile with the right extrusion. After, you have to get all the SQA, all the validation. So it's really burning our business because, of course, if you are a customer in your car, for example, you go to the garage and you say, can you change me this door? And the garagist said to you, wait 2 years. Of course, you will laugh and you will say that's not possible. But this is happening in the right way. So we really have, it's unacceptable. We really have to change that, and this is how Wabtec is trying to do it. Thank you very much.
Thank you so much, Henri. That was very interesting, and we will get into a short discussion later. So if you have any questions, please feel free already to write them down. Now we're coming to a different field, which has a bit in common with the rail industry, because we're also talking about usually heavy metal and not small plastic hook hangers. So I would like to ask to come on stage Martin Huber. Martin, you have a technical background as a tool maker, engineer, and of course, military expert. You worked for Siemens and the German Armed Forces, Bundeswehr, with deployments abroad and inland. And you're now responsible for the last year, since 2018, for the implementation of AM within the EU armed forces. And I think this is really interesting because we're talking so much about military use cases on country levels, and you will do this on a more global and EU level. So we are really keen to hear what you're doing at the moment. Warm hand of applause for Martin Huber, please.
Ich nehme mal den Prompter da. Merci. Yeah, ladies and gentlemen, Stephanie, thank you very much for having me here. My name is Martin Huber. As you heard, I'm working for the European Defence Agency. And I would like to reflect on that. I want to give you an entire picture on that, what the European Defence Forces are doing in terms of additive manufacturing. And therefore, I want to answer the following questions in 15 minutes, which is already quite challenging. So first of all, who is EDA? Why we are dealing with additive manufacturing, how we are dealing with additive manufacturing, and what are the challenges. And you will see in the challenges that they are similar to the other heavy metal areas, or we are facing all the same problems like the armed forces as well, but we have different specifications. I will dive in a little bit later during my presentation. Who is EDA? And this is EDA. We are an entity, an official entity of the European bodies. There are 26 European agencies. And there are, for example, one agency is in Cologne, is the EAS, or the agency for fishing, it's in Vigo, and in Parma. You can imagine what is in Parma, an agency for, okay. But for defense, it's in Brussels. What makes us special and unique? We are the only agency who has a steering board on minister level, And, by the way, the head of the agency is his High Representative of the European Union, Mr. Borrell. And that makes this connection between defense and also the External Action Service, so let me say European foreign politics, quite visible. And we do this with my colleagues together. We are an agency with 180 people, but since, let me say, the conflict we have at the east side, the east border of Europe, the projects are increasing significantly, and therefore also, let me say, the number of personnel, of staff is increasing in the same way, in the same steps, in the same level. You see that we have 27 member states. We have also some administrative arrangements. This is a policy-driven story, but you see here also the Ukrainians are important since last year, which is not reflected on this slide. We have also an administrative arrangement with the United States. So this is, we hope that is fostering cooperation in defense matters. And we see that quite clear already in additive manufacturing. We are getting more and more in contact with the United States. I will come back to it later. Why we are an agency, what is our purpose, what is our objectives? We support the Council and our member states in terms of the efforts and the implementation of military capabilities. And I'm a capability developer. I'm not a researcher. So I put hands on processes and try to implement something. And this is something I will reflect later in my presentation as well. Why are we dealing with additive manufacturing? So, conceptual-wise, we have some analytical tools, and one tool, and this is the so-called CDP, Capability Development Priorities. We had last year the fourth review on it. So we dive into, we use different instruments, and we look where are the military capability shortfalls. And maybe of interest for you is also there is a connection between the CDP, the CARD, the Coordinated Annual Report Review of Defense. So this is also drawing a picture on the capability shortfalls on the one hand side and the connection, for example, to industry, to research. And at the end, they all lead to PESCO. Maybe you have heard already about the PESCO projects and to the EDF, to the European Defense Fund. And let me say this is in this regard interesting for you because when you want to get in touch or you want to develop a business case with European defense, then this is the funding for that. This is the pot where the money is in, and you can look it up on the internet. The informations are available how to get in. Why I'm dealing with additive manufacturing? Because in the CDP priorities of 2018, they found out that AM has the potential to reduce the so-called logistic footprint. And since we are servant for the member states, now we facilitate all activities within EDA for the member states aiming to develop a military capability. And how we are doing this, or what do we consider as a logistic footprint? For us, a logistic footprint means we want to reduce, let me say, the on-site inventory, and this is based on the potential of additive manufacturing by its nature, and also saving costs and capabilities. You can imagine that when we have a deployment anywhere on the darkest areas of this world, that you have to establish a supply chain. And we see the potential that additive manufacturing can have benefit to reduce the effort to keep these supply chains alive and ongoing. And of course, one factor is also saving human resources. Every soldier we do not have to deploy into theater is a soldier we do not jeopardize his life. And we have a, let me say, a generic interest to stay as alive as long as possible. So this is one also of the factors we are facing the same problem that the armed forces, they are lacking staff and personnel. So there is a technical solution for it, and it might be additive manufacturing. I will not dive into the other topics, but there's also, let me say that in that way, European strategy. We see the potential in additive manufacturing to reduce the dependency on so-called critical raw materials, notably it's titanium or chroma or whatever. And we see the potential that AM materials, and we think that it's not at its very end of development, that they can replace those materials. Having in mind that all these, let me say, more than 17, most of the assets we are using in the German armed forces, they're in the average 70.5 years old. And you can imagine they were engineered, developed, designed 20 years ago. And 20 years ago, the most of the engineers sitting in the engineering department in your companies, they did not have additive manufacturing in mind, and not even the new materials. So there's a kind of a potential there, a massive potential for us to reduce this footprint and to get an operational benefit. How we are dealing with that? We have a threefold approach, and we do that in the way that we have 3 work streams. The first work stream is AM Village. That's a 5-day capability workshop where we're gathering people together. We have a symposium established, European Military Additive Manufacturing Symposium, and a CAT-B project, Additive Manufacturing for Logistic Support. Briefly to the AM Village, 5 days capability workshop. We had it last year in Ede for the very first time. We gathered together academia, militaries, and industry. They are willing to cooperate 5 days in a cage, and we do nothing else than additive manufacturing in a military context. And we are right now preparing the second edition of the AM Village, and it will be in Toornlijn in Belgium under the umbrella of the Belgian presidency. And I can say already right now that we will have much more than 250 participants the next time. We are moving now in direction 400, even more than 400 participants. And that will take place in a military installation, the logistics school of the Belgian Armed Forces. And we are looking forward to that, to do additive manufacturing from the nerd perspective. The second approach is AM Symposium, where we address, let me say, the requirements of armed forces in terms of additive manufacturing in a military context. We do that in a 2 years approach in a cooperation with the German DWT. And most likely the next event will be, the third event will be in April, May next year, once again in Bonn. Talking about this category project, and this is actually, let me say, the main project where we are diving in, talking about additive manufacturing. What is the purpose? We want to determine and elaborate common standards. And you see in this gray box over there, you see the areas we have identified in several workshops together with the armed forces. What are the areas where we need harmonization, standardization, and where we can elaborate standards? Of course, we reach back to standards already existing, but as you can imagine, for the armed forces perspective, there are some standards that are not available in the market because they're very specific military-wise. So we put hands on that, and we develop our standards in these areas to foster cooperation and to achieve interoperability, one keyword, and interchangeability. What are the challenges? And now I have 1 minute left. This is a not in written stone timeline how we approach from a military perspective additive manufacturing. We figured out that battle damage repair, this is a special keyword, but these are assets, they're anyhow damaged in a battle, in a war situation, and not to lose them, you do some maintenance on that just to pull them out, to bring them back, and to fix and maintain them, that they are operational ready again. So this MacGyver approach. We figured out that additive manufacturing actually, or the technologies available, they are not suitable for battle damage repair from an operational point of view, but we have identified expedient repairs and maintenance as suitable, and this is something we are focusing right now. So you need to understand that the armed forces are just in the beginning of exploring additive manufacturing. You guys, you do that already for a while. We do that since 2018 right now, and the most of the member states, they are dealing with AM still in the research domain, and just a few of them, they are already a step further. For example, the Deutsche Bundeswehr, they have an implementation project right now to implement additive manufacturing. One word to temporary replacements. This is something we consider because, let me say, you can imagine when you are deployed on a mission or whatever, that the availability of spare parts is mandatory to keep the operational readiness. And we are thinking about it with a temporary replacement until the OEM part has been delivered, just to keep the functionality alive. So this is something we are elaborating as well. And last but not least, obsolescences. I will not dive in because you know that much better than I. We have the same problems in the Deutsche Bahn. And future procurements. This is something which is more the strategic approach. And I will dive in. I pick now one of the challenges out. And this is something I want to address to the OEM. When I walk here through, and I walk through the forum next, and I walk through all these exhibitions, one thing is, and this is my imagination, the industry is ready. There are the machines, we have the technology, we have knowledge, we have experiences, we have even a bunch of standards available. So what's the problem right now for armed forces to get use of additive manufacturing? The problem is 17 years old assets in use in the average. The OEM has not prepared the next century because they are still, most of them, they are focusing on the classic way to design, and then they bring the products on the market. Specific, the defense industry is very conservative in this regard. And we would like to see a little bit more engagement and a courageous engagement also in this regard to develop the products also with a dedicated approach on additive manufacturing design as much as possible, that we can get use when we are deployed on additive manufacturing. 2 minutes too long. I'm sorry. Ladies and gentlemen, I'm for your disposal for any questions you might have. Thank you very much.
Thank you so much, Martin. So I come from rail. 2 minutes is okay. Now, we would like to ask you to raise your questions, and you've done this already. And I was really astonished, so that sustainability plays a big role in rail, that we know, Henri, for quite a while now. That it also plays a role for the armed forces, being prepared for war times and being active there. That might sound a bit astonishing. How do you think about that, Martin?
Sustainability is, let me say, in terms of logistics, it is one of the key challenges we have, specifically when you look now in the operational domain, what happens in Ukraine. I'm not sure if you're aware of that, but logistic forces, they have to be agile, sustainable and agile. And they change the position with the changing war scenario right now because of these drones threats. They have to change their position at least all 48 hours, between 24 and 48 hours. That means the logistics we are used to apply in the military from, let me say, the time after the Cold War or whatever, these very unflexible and not agile logistics, it's not suitable anymore. We need flexible and agile logistics. And I think that specifically for sustainability and having in mind what I was saying about the OEM and temporary spare parts, additive manufacturing can potentially contribute to give more agility to armed forces, specifically in a crisis scenario.
Thank you so much. So then we have a question. What are the challenges to qualify the optimized products at the OEM? Henri, can you answer that?
I would say that it's exactly the same process that the one we are doing for the conventional part. It means that you have to go to, if it's a pneumatic part, for example, source spray test, overpressure, vibration test. So it's exactly the same kind of test that the one we are doing for conventional parts. We are just adding some qualification due to the technology, such as coupon sample. We are checking also the powder and all that stuff. But this is really what we are doing. The challenge is really coming for spare parts, because you have to prove to customer that the spare parts you are manufacturing in additive is exactly fitting, at least respecting the same standard, or get a better properties than the one they have in the train. And for that, and if you are working on simulation, I think you have a good future for this kind of problem, is how to help us to simulate, according to the orientation of the part in the printer, the fatigue result of the part, to be able to be much faster on the qualification. To give you an idea, to qualify a part which is already in service on the train, it's taking us 2 years again. 1 year internally to get all the static, dynamic test, the test on the test bench, but each time we have to go on the field test for at least 1 year of field test on the train.
Thank you. So you have to be aware that you need a bit more of time. I would be really interested also, I think this is a very good question, qualification, certification, and maybe also other takeaways. was your impression of the last AM Village, Martin? Do you have the same problems?
Yeah, we are facing exactly the same problem in terms of certification, verification, and so on. We have identified a lot of, let me say, capability gaps in terms of getting use of additive manufacturing. One is battle damage repair as a lesson learned, but we are lacking common standards. And where we want to go to, we want to come to the situation, and this is mainly legal aspects driven. We want to come to the situation that, for example, a Spanish deployment is able to support French forces with a German vehicle, that something is lacking, and this is where we want to come to. So we are talking about common recognition of the national standards, the national processes, and this is also mainly, as I said, legally driven, and this is one of the bigger challenges we have. And yeah, we are facing this situation. I'm quite confident in that.
I would be really curious how the former producers will react to that if someone else is repairing their parts. But
I think we are in the same environmental, and we are depending on each other. And I think the best way to solve this, and for us it's not an issue, it's simply a new situation. Just imagine how, let me say, the classic procurement way from armed forces, we have to rethink this as well in terms of additive manufacturing. How do I pay in future? So when we do the spare parts contracts or whatever, at the moment, we are focusing on numbers over a timeline. Of course, we need also to look on numbers over a timeline, but maybe in future we need to talk about downloads or whatever. So we have to rethink the way of reimbursement and the costs, and I think this is a win-win situation for both, for industry and also for the armed forces. Let's talk.
What are the most important AM technologies for the rail industry or for trains?
That's a very tricky question. I mean, there is, as all the experts before us have said, there is no dedicated technology to make a couple of parts. Each time you have to think about the cases and identify the right technology to make it. So of course, DMLS is something that we are using a lot because also it's the most mature technology today. But you have one application that you have made at Deutsche Bahn, for example, which are amazing example. You have also rapid casting to be able to print the mold and to be able to have the part only because you need 1 or 2 pieces and not 40 like they used to do in casting. So it's really according to the scenario, to the part that you would like to manufacture.
Thank you. So I just can comment on that. At Deutsche Bahn, 12 different technologies are used. Maybe we can report on that the next time. What was the technology for the train door case? I mean, we all saw that example from Boeing, and we do not want to experience this in rail. So
no, sure. It will not be the case, I can tell you. Why? It's because, again, as I was saying, this is a safety part. Each time that we have a safety part, we have to qualify it. So the part you have seen printed was on the mock-up, on the train mock-up, and we were launching the test. We will put a lot of sensor on it, and we will force the part to open, the door to open, simulating a crossing of 2 trains at 350 kilometers, and to try to extract the door and see if everything is fitting. So the technology used for that was the DMLM process, a powder laser bed. Of course, not at 2 meters because it's not existing right now. At least we don't have it internally. But we have made a kit to be able to manufacture this part.
Thank you so much. I mean, we are all confronted with the news at the moment, and a lot of the news come from Ukraine. And that is some kind of a test field. That sounds a bit cynical, but I think that is a bit true. So concerning the AM usage, also war of drones, what can AM do and what is done in the Ukraine?
Let me say, the Ukraine forces are using additive manufacturing in many regards, not only for drones. Let me say the production of drones is one of the aspects, but it's not the main aspects. The main problem the Ukrainian forces are facing are the lacking of spare parts, specifically for these post-Soviet or the old Soviet assets. You can imagine that the original equipment manufacturer is becoming your enemy, then you do not look that closely anymore on your contracts, IPRs or whatever. I would say this is actually the situation we are facing. It's about reverse engineering, and afterwards the reproduction, the remanufacturing of the parts to keep these assets alive. And this is very interesting to look a little bit more into detail how inventive they are and how they do get the potential of additive manufacturing, reverse engineering out, just maintaining 30, 40 years old assets. That's very interesting. It's also a lesson learned. And I'm quite glad that we will reflect on that also at the upcoming Additive Manufacturing Village in Tournai. We will have some colleagues and comrades from Ukraine, and they will talk about this.
So unfortunately, our time is already over, but you will be around.
Sure.
So this is also what the both sectors have in common, because also the Ukraine railway company is lacking of spare parts where we could help.